Good morning, everybody. So Yogesh, I think, gave us a great setup. He talked about a couple of different things. Clearly, AI is in the forefront of everybody's minds, and the data platform is the platform we believe that can help you with your AI initiatives. But it's not just about AI. And so part of what I want to do this morning is talk a little bit more about data and search and some of the other evolutions that have happened and how they become part of the platform and are still relevant today. Yogesh also talked about the history of progress. I'm going to talk about the history of technology. I want to begin with sort of a key point, which is technology has evolved. Right? The title of the presentation was from queries and keywords to insights and agents. And technology has evolved even during the time that I have been in the industry. Right? I haven't been in the industry quite as long as Yogesh, but I've been around for a little while. And as technology has evolved, technology continues to build upon the foundations from previous generations of technology, continues to provide new innovation. And I want to take us through that. And at the end of the sentence there, you'll notice a little period. We are in a spy museum after all, and so that is a microdot. And so we're going to use that as the basis for the journey. So I'm going to take you through the journey as I've seen it, at least during my career, mostly to bring us to the point where you realize the relevance of those technologies today. So my first real interaction in the IT industry was sort of back in the 80s. And I was working on a system in the UK, which was responsible for managing the blood supply, right? Getting people to come and give blood, taking that blood, getting it through the labs, getting it tested, making sure it got processed, making sure it got to the hospitals. I was relatively young at the time, wet behind the ears, and I was asked to implement a Soundex algorithm. How many people in the room know what Soundex is? Only the older people in the room know what Soundex is. So Soundex is an algorithm that works primarily in the English language, but does phonetic matching. So words that sound similar get encoded with an encoding, and so when you do a search, you can find names that sound similar. So Smith, Smythe, things like that. So I was implementing the Soundex algorithm, and I was talking to my boss at the time, and he said, the key here is to give people the information they need, not necessarily what they ask for. If you can understand the intent, you can present information in a way that perhaps the question they asked wouldn't give them the answer, but you can provide additional context. And that really stuck with me. Little side note, as I was preparing this presentation, I was telling this story, and I was talking about the fact that this happened in 1985, and one of the people in the room said, "Oh, that's the year I was born." I said, thanks. So this is the start of my journey. And Soundex was, I think, an interesting starting point because you didn't ask for something, but you get it that may be useful. And I'm going to take us through the evolution of these technologies. And remember, just because the technology has been around for a while does not mean that it's obsolete. Yogesh talked about OpenEdge, which is the foundation of Progress, the company. OpenEdge has been around for 40 years. And as he said, right, there are tens of thousands of businesses worldwide who run on applications built on OpenEdge, right? ERP systems, CRM systems, the kind of things that you'd expect. And we'll come back to that a little bit. So as we start to take a look, I'm going to divide the conversation into three parts. What's happening in the world of databases, what's happening in the world of search, and then what's happening in that convergence between them. So in the early days, back when I started, we started with database models, and then the relational model became prevalent. OpenEdge is a relational platform. And in the 1970s to the 1990s, these two worlds of data and search were largely separate. So in the data world, we had an ER model, we had relational models, we had SQL, primarily online transaction processing, ACID compliance, for those of you who live in this world, right? Atomic, consistent, isolated, and durable. It is very, very important, but it's primarily on very straightforward, simple data. So no rich data types, no documents, very limited analytics other than what you can do with SQL, no unstructured data. So relatively straightforward, spreadsheets writ large. In the world of search, we had some early information retrieval systems, Documentum, things like that, primarily focused on text. And the key down the bottom here is Boolean logic. The expectation was that if you had something fairly complicated to ask, you'd be smart enough to figure it out, right? With Boolean logic, you could craft a query and get an answer from the system. We move forward a little bit, data starts to get larger, becomes more critical, and we start to see the evolution of data warehousing and the data layer and early web search. And so if we think about what was happening at this point, now data is becoming so large that the query itself takes too long to run to give you the answer. And so the evolution of star schemas, the evolution of OLAP, pre-processing information so that you can pre-calculate aggregates so that if I want to know, for example, how much of a product I shipped in a particular region at a particular time, that aggregate has already been pre-calculated. Those facts, those dimensions are already there so that I can get a response time that makes sense. And this is clearly where the evolution of data pipelines, primarily ETL, right, extract, transform, load the data, become important. And as Yogesh mentioned, with our Data Direct portfolio, we have products in this area that are embedded in the majority of the major ETL platforms that are out there. Down on the search side, you get things like Lucene, Alta Vista. How many people in the room remember Alta Vista? Quite a few people. I'll talk about that in a second. And this is really full text search based on statistical algorithms, right? Statistical relevance. We'll see that in a second with a screenshot. But the key here is there's no semantic understanding, right? Tell me about an apple. Am I talking about fruit or am I talking about a computer? Really, you don't know, right? There's no context. It's purely keywords and the number of times that those keywords appear. So for those of you who don't remember Alta Vista, this is what it looked like. Clearly, the browser gives it away. But Alta Vista was, the search engine of its time. And the reason I put this up isn't just a trip down memory lane, but it's to bring this second screenshot. And so what you see is there is some flexibility in searching, right? I can look at queries by language, I can look at queries by date, and I can construct a Boolean expression. And that was the expectation. You want to ask something that's more than just a very simple query, you go learn Boolean. Very, very different from the natural language processing that we have today, but fundamentally foundational to getting to the stage that we're at. So if we go back and we see where we are, what was the convergence? So at this point, and I remember it, in the 90s, this is the emergence of early dashboarding systems, sort of tools that allowed you to do basic querying with some SQL if you were smart enough, some Boolean if you had that capability, some text. I remember working with products like Forest and Trees and a whole bunch of other ones if you remember those. But BI dashboards that allowed you to index a little bit of text as well as what was happening in the data world. Then we start to get to the really interesting part. So late 90s to the 2000s, the introduction of native XML systems, right? XML becomes really important and is the basis today for many standards, right? Those of you in highly regulated industries, right? Financial services, looking at fraud, healthcare, regulated manufacturing, XML is and always will, I think, remain a foundational element. And so this is when we see the introduction of MarkLogic, really encoding and natively managing XML. Down on the bottom in the search world, we start to see the emergence of Google and things like PageRank. So now the data volumes are increasing. We start to do ingestion and crawling at a much larger scale. And the notion of relevance. So PageRank was intended to introduce relevance or the concept of relevance, right? The more pages point to my page, chances are I'm a definitive reference or a definitive source, so I should rank higher in the search results. Also, the evolution of an entire industry of search engine optimization and people making money on figuring out how to do that. In the middle, really now we start to see the XML XQuery to allow us to navigate across these documents, to be able to search, to be able to manipulate. So XML XQuery become really important and foundational to the platform. Then we get into the 2000s. And in the 2000s, we start to see really a move beyond text and numbers, right? Text and numbers being the data that we had primarily in those relational systems, in the early search systems. And now we start to see time series data, we start to see geospatial, we start to see other things emerging, which all help give context to the data that we're looking at. And I want to just show a quick example of this. And this one I often show when I'm talking to the OpenEdge audience, because remember, OpenEdge is a relational platform. The relational model is a great way of looking at data. right? Here we see on the screen a list of things to see in DC. So we've got the tourist site, we've got the name, we've got latitude and longitude, we've got some kind of ranking and some internal identifier. It's great. We've got a list of things I want to go and see. If I start to look at that in a slightly different way, I now get a different insight. So courtesy of Google Maps, if I look at that same data represented in the map, now I get some idea of proximity, right? If I can only see 2 or 3 of the sites and I've got a finite amount of time, which ones am I going to go and see? So putting the data in the context of the map gives us a slightly different insight. Looking at the satellite image, if it stays up, instead of the map, gives us even more of an insight. And really, when you bring it all together, now we add traffic, and clearly I took this at a time which was not right now, because there's lots of green. But now I start to see not just, could I do it because of physical proximity, but does physical proximity actually match to temporal proximity, right? Could I actually make it to go and see these sites? So bringing all that data together from just the relational format, now bringing in, geospatial, we'll talk about time series in a second, gives you different context and much more usable information. But if I go back to my little picture, where are we? So we've got the addition of these new types, so time series, geospatial, the introduction of graphs. And in the search world, something else that's happening that's very interesting. Back in the early 2000s, this was everything starts with the letter E, right? Everybody was e-commerce, E this, E that, E the other. And so we started to see the emergence of platforms like eBay and Amazon with guided navigation, guided search, with what we call facets, right? So instead of you having to know what products you potentially could look for, based on what you've asked so far, here are a list of categories that you can select from. So guided exploration, guided navigation, some discussion of distributed search and temporal, and the emergence of some algorithms like BM25 that I know MJ is going to talk about. So what does this start to look like? Well, here's an example of an application on a crime scenario. So this is a law enforcement scenario. A law enforcement professional, perhaps is working a case and they're looking to see if related events or incidents may relate to the case they're at. The reason I put this up is those of you in the room who are not familiar with FastTrack. FastTrack is an evolution that we've done on top of the MarkLogic platform since the acquisition of MarkLogic by Progress. This is a FastTrack application. And what FastTrack allows you to do is to build applications that look like this without having to know and expose a lot of the underlying query technology. So it makes life much, much easier for the application developer. So what do we have here? We have events represented on a map. Clearly that's similar to the example I just showed with the Google Maps. Down at the bottom, we have time series. I could scroll the time series, use that for selection. I could draw on the map to do selection there. And I have a list of events or incidents over on the side. What's also present in FastTrack and MarkLogic is automatic faceting. So based upon the data that's available, generating that guided exploration automatically so that you can navigate and get to your answer much more quickly. So back to our little map for a second. This is also when we start to see RDF, which was the basis for discussion around things like semantic web. We see triples, we see the introduction of OWL, Sparkle. So that convergence is now really starting to take hold. And then we get to the 2010s. We're almost at today. And in the 2010s, again, data is exploding. So now structured data is exploding, but unstructured data is exploding at a much faster rate. So now we have social media, we have video, we have voice, we have text. We have a lot of data that is available. And so we start to see the evolution of big data. We see things like Hadoop. Down in the search layer, now we really start to see embeddings. We start to see semantics becoming important. This is where semaphore comes into the picture. We start to see entity recognition based upon context. So now an apple is either a fruit or a computer, and you can determine that context based upon the place in the document, the other things that are being discussed. We start to see embeddings start to happen. And this, I think, becomes the basis for the next and current generation, which is this native AI convergence. And this is really where we are today. So a single platform that allows you to manipulate all of the data, whether this is XML data, whether this is JSON, whether this is graph, whether it's triples, whether it's whatever it is, all within a single platform. Down on the search, as Yogesh mentioned, we now start to see the emergence of these large language models, right? We start to see the introduction. And this really brings us to the middle. And the middle is, hybrid queries, again, structured, unstructured, all of the data, with retrieval-augmented generation. Now, Yogesh mentioned RAG quite a few times in his presentation. I just want to do a sort of a quick sanity check. How many people are familiar with RAG and have done some sort of exploration with RAG? So some in the room, but not everybody. So the slide that I was going to hide, I will put up. So Yogesh mentioned this, but RAG, which is retrieval-augmented generation, a term that was first used in 2020, interestingly enough, so prior to the advent of things like ChatGPT. And what this does is it enhances the activity with the LLM by grounding it by first doing retrieval and then passing that context to the LLM. So let me do a search against my own repository, find documents, context, and information that I think is relevant, and then pass that as context as part of the prompt to the LLM. Now, here it says, relevant context from a vector database or search. With the Progress Data Platform, that grounding is done through through the combination of semantic querying, vector querying, search querying with enhanced algorithms, graph, everything that's in the platform today. And what this does is it ensures that the LLM generates a response only on the context that is passed, not attempting to please you by saying, you know what, I scraped the entirety of the internet, I can make something up that sounds plausible, but if I can't answer the question from the data that is provided, then I can't answer the question. Yogesh mentioned with Progress Agentic RAG this notion of the RAG evaluation metrics. Did I get an answer at all? If not, I have a knowledge gap, right? Because if I didn't get an answer, there was nothing in my private repository that I could use to ground the LLM. Did I get the right answer? Well, maybe my knowledge has both the right answer and the wrong answer, and now I have a knowledge quality problem. How did I get the answer? Right? Maybe I have 100 or 1,000 documents in my repository that looked relevant, but actually only 10% of those ever get used in answering queries, right? Now I have a knowledge curation problem. So this is some of the things that we can start to do with RAG. Limitations, we'll get to in a second when we talk about the next evolution. But RAG, I think, the use of your private data in a secure manner so that it doesn't leak into the models is the key of what RAG is all about. And the data platform and our agentic RAG solutions do this as well as any solution that is out there. MCP is another term that we've all heard. How many people are familiar with the term MCP? A few less hands this time around. So MCP, which is Model Context Protocol, was a term that was coined in November of 2024. And this is how quickly this space is moving. And what MCP does is an extension of RAG. So this is how we get to agentic RAG instead of traditional RAG. Can we call something traditional if it's only been around for a couple of years? And what agentic RAG does is provide additional sources of information and context to the LLM. Something called tools, where when it's processing the query, the LLM can actually reach out and get real-time information from a service to help it with the answer that it's going to provide. Now, if you think about the data platform model, we ingest data into the data platform, we harmonize it, we give a 360-degree view, which I'm going to talk about in a second. Not all of that data should be in that repository. Some of it is highly volatile, it's changing very frequently, and even if you have a low latency transfer and population, you still don't want to be doing that. You want to get live information, right? Think about active inventory or status of something. And so what MCP does is it moves from ask and answer to here is the goal, build a plan on how to answer it, retrieve information, act upon it, and then explain what I did. And I'll show you an example of that in a second. So why is all of this important? Why did I take us down the sort of the memory lane? None of the technologies that I talked about are obsolete. Everything remains current. Business today, right? 90% of business decisions are based upon structured information, right? Information in CRM systems, ERP systems. And those, for the most part, are based on relational and relational extended systems, right? The search patterns that we talked about are foundational to help us do RAG. And all of this is to enable you to build a 360-degree view of whatever it is that your business cares about, whether that's your customer, your product, your competition, your employee, whatever it is that you're primarily focused on. How do you get access to all of the information you know, regardless of how many systems it's spread across? I know there will be presentations, the rest of the conference, where people talk about, ingesting and integrating information from not tens, but hundreds of different systems. Example I'll show you in a second only has a couple, but I think it's illustrative. So how do you connect to the data that exists? How do you bring it together to create new insights and harmonized versions of that? And then how do you prepare it for consumption using the kind of intuitive interfaces that I showed with things like FastTrack? So this is what the Progress Data Platform is all about. How do we enable you to bring disparate data scattered around your enterprise in different sources, different databases, different formats, and bring that together to get intelligent insights, where there is connective tissue, connections, and semantic understanding and context of all of that data relating to the problem or the task at hand. So the example I'm going to give you is an example from a fictitious company called ProRailing Solutions. Yogesh mentioned, and I mentioned a couple of times, that we have lots of our OpenEdge customers who've built ERP applications. What's interesting is that a lot of those applications are focused on relatively narrow parts of the market. An example I picked for the demonstration here is building materials supply. There's some really interesting things in the building materials supply that you get into about pallet splitting and all sorts of other stuff. But ProRailing Solutions, fictitious company, but fairly standard, right? They've got an ERP system, perhaps built on OpenEdge, perhaps not. The demo actually uses live OpenEdge data. They've got a CRM system. They use SharePoint for managing documents. They've got things like customer information, memos, product documentation, warranties, all of the stuff that you'd expect. And what they really need to understand is what's going on. And so the illustration that we put together using FastTrack hopefully will set the tone and give you some ideas about what you may be able to do. So here's ProRailings. If this works and you can read from the back, if I log in, I'm going to see a fairly standard dashboard, again, built using FastTrack. So I got some information about some recent orders. Over on the left on the menu, you can see I've got some graphs and agentic RAG. I'm going to get to that in a second. But over on the right-hand side, there's a bunch of alerts. Now, these alerts would have been generated by monitoring in the warehouse, processed through a set of business rules to determine whether they were relevant to show up, business rules being our Corticon platform. And what you saw there was a bunch of alerts about something in the warehouse. Going to get back to that in a second, but I'm focused on my customer support. So I have a couple of tickets, and two of these tickets seem to describe warping, right? Products that are warped and unable to be installed. So a product is slightly warped. One of the products here is a product called Fence 2002. That's the SKU. I'm guessing that's a fencing product. If I go back and look at the other ticket, the middle one was damaged in shipping, so that's probably not related. Here I see another one. Product is also slightly warped. And I was originally going to guess that this was the same fencing, but actually it's not. This is a product SKU called Fast 3003. Not 100% sure what that is, but we'll go figure it out. So how could I figure this out? Right? Yogesh talked a lot about AI, and AI is very important, but there's lots of ways that I could figure this out. But given that AI is here, we'll first go and ask our AI assistant. So I'm going to ask our AI assistant, what is the relationship between those two product SKUs, FAST 2002, excuse me, FAST 3003 and FENS 2002. And this is where you all realize that I should have pasted instead of typing the answer because it's a little slow. You also get to critique my typing. And what I see here is, the fencing uses a hidden fastener system, and so clearly they're related because you use them together in a particular installation. Now, what's also fascinating here is that there's two answers. One comes from the product documentation, which you would expect. The other one comes from a memo about something that was going on in the warehouse that may have affected the quality of those products. So I can ask what causes warping, and again, I get an answer. Warping can be caused by whatever it is. And in the demo, I'm not clicking into the citations every time, but clearly I could go back and look at the original document. And so I see that warping was caused by exposed moisture. And so I asked the question, have we had humidity in the warehouse that may have caused these problems? And the answer I get back is, looks like we did, because there were some memos about moisture, which are largely, I suspect, related to those alerts. Which warehouse was it? St. Louis is going to be the answer, STL01. If I'd been paying attention when I looked at the alerts, I would have seen that, and maybe I could have started there. So I used AI to sort of help me get to a point where there is a relationship between these products. Those products have something, perhaps there's moisture damage. Slight aside, when we were putting this demo together, my first thought was, why would anybody buy a fencing product that can't cope with moisture and heat and humidity? Right? It doesn't seem like a good thing to do. But it turns out that actually this is a real scenario. Fencing, once installed, it is largely impervious to weather. But the internal parts that don't get exposed to weather, in many cases, are actually highly susceptible to storage and transport. So it's a real scenario. So we're going to go look at the warehouses. And again, this is all FastTrack. So we used an AI assistant with RAG. So RAG, remember, querying our internal repository of documents, passing that information as context as part of the prompt to the LLM. When I start to look at the warehouses, now I got a different view. So MarkLogic, as you all know, stores graphs, relationships. And so here we have a representation of a couple of different warehouses and a couple of different orders. And so purple was the warehouse, yellow was the consignment, blue is a product, purple is an order, and green is a return. And so you can see the return is related to an order, the order is related to a product, the product came out of a consignment, the consignment is in a warehouse. Great. I can also use something which is native to MarkLogic in MarkLogic 12 called shortest path analysis. Show me the shortest path from the return to the warehouse. What you can see is the navigation was highlighted on the graph. So I can very quickly get from I have a return to where did it come from just by asking for shortest path analysis. If we look at a different one, different return, you'll see that one also pointed at St. Louis. And the third return, which if you remember was damaged in shipping, if we take a look at that one, that came from a different warehouse, and that warehouse was in Dallas, so clearly not related to the case. So we had two instances in the graph where shortest path pointed us back to the St. Louis warehouse. Clearly, St. Louis is where we need to go. Okay, how are we done on time? 15 left. So let's go look at St. Louis. Right? Those of you who were paying attention in the room said I should have done that about 15 minutes ago, because clearly that's where the alerts were. But I'm going to go and look at what's happening in St. Louis, hopefully. Did I click? I guess I didn't click. There you go, I clicked this time. So we're going to look at the St. Louis warehouse, and here we see a different representation. Same elements, right? I've got the warehouse, I've got consignments, I've got orders and returns, but now I'm looking at this more on a timeline view. So what I see is the orders in purple, but up at the top, I also see the events where there was a major storm, the storm caused leaks, and we had humidity and damage. The orders, as you can see, are in purple, and you can see how those orders were shipped after that first event. And now what we're looking at is a return on the green line. That return is linked back to an order. That order is linked to a consignment. That consignment was in the warehouse at the time that the damage occurred. Now what you can see here is, clearly all of these first group of orders were shipped after the first adverse event. Then there was a bunch of other adverse events, but no orders were shipped, which is good news. It feels like the people in the warehouse were able to get a handle on the problem. They stopped shipping orders while they worked on remediation or whatever the problem was. I could also look at St. Louis just more directly, and this, I think, shows you a clearer illustration of here is the shortest path from returns to the warehouse, and I can flip that upside down if I want to start with a view there. So hopefully you're getting some sense of, AI is important, but AI is not the only way you can get insights into the data you have. Visualization, contextual understanding is also another mechanism. And when you really bring those together is where you see the power of the platform. So what about agentic RAG? So agentic RAG, if you remember, I said a few minutes ago, was based on the MCP protocol, Model Context Protocol. And so what that means is that the LLM has access to other information. And what you see over on the right is some of the information it has access to. So it has access to consignment records, inventory records, a bunch of other information that it can access real time. Now, the way this is implemented is these MCP servers are registered with the LLM, and when the LLM is trying to figure out how to process a particular query, it knows it has these tools available to it on which it can act, it can gather information. Now, the example here, and I'll click to it in a second, the MCP server is implemented against an ERP application written in OpenEdge, which means that we're actually going through the OpenEdge business logic to get to the data, not just the data itself. And that's important because clearly you don't want to be exposing raw data, particularly if the schema is somewhat convoluted. You want to make sure that it processes through the business logic. So how does this work? Well, for the purposes of the demo, we've exposed a little bit of the plumbing. And so what you can see is we ask a first question, and the first question is, what products were affected by the weather event in the St. Louis warehouse. And you can see agentic RAG is thinking. It first rephrases the query, which is great because often I make a typo or I spell something incorrect. And then it says, wait a minute, I have these MCP servers available to me. And one of them is to get information about memos about what was happening in the warehouse. And so it called that MCP server, and the answer we get back is the answer you see on the screen, which is these products were affected. And the reason I know that is because there was a memo written by the warehouse manager that talked about a particular pallet that clearly got wet or damp or whatever it happens to be. So agentic RAG is doing something very similar to regular RAG, but in this case, the information didn't come from knowledge and documents that I'd assembled into the vector database. It comes from a live query to a server, which is giving us real-time information from an application. We then ask a more business-relevant question, and this is where you get to watch me type again. So excluding St. Louis, do we have these products available in inventory anywhere else? And this is, as I mentioned earlier on, while some of the information you will want to ingest into the data platform and have it available, some information you really want to query real time. And so the query is, excluding St. Louis, what inventory do we have? Detail the amounts at each of the warehouses that is available to us. And what you'll see is, again, agentic RAG is thinking. I'll rephrase the query, because my English clearly was not great and I didn't mention the products. And then you see the query there. Get inventory records with a filter of these SKUs and or location, which is not equal to St. Louis. So agentic RAG is doing its thing. It's calling the MCP server. The MCP server returns the response, and the LLM rephrases that and gives it back to us. And so now we've had, in the last few minutes, an example of using visualization to understand context, right? Using alerts, using RAG in its more, quote, traditional form to answer questions, as well as agentic RAG to really get us to the final solution. And all of this was done as an application written on the Progress Data Platform. So MJ will be taking us through the Progress Data Platform after the break. But if you look at the picture, it really talks to the ProRailing Solutions environment that I mentioned. So they have a content management system, they have an ERP, they have a CRM. This particular case, we didn't have a PLM or a product lifecycle management solution. And within the platform, we were able to connect to existing data using connectors from our Data Direct portfolio, which you can see in Demo Alley, using native drivers to their platforms if they're out there, third-party connectors, and then using technologies like Flux to orchestrate the ingestion of that. Within the platform itself, we enrich the data by providing fact extraction, semantic understanding with Semaphore, bring that together, perhaps apply business policies and rules with Corticon, which is also available there. Indexed and stored, of course, in the MarkLogic repository, and then allowing integrations out and built as the visualization layer using FastTrack, which, by the way, is built on top of that tooling layer that Yogesh mentioned right at the beginning, right? The developer experience tooling is the foundation for FastTrack. So hopefully that brings it all together and gives you some insight into why the Progress Data Platform has such a focus inside Progress. Because we believe that not just for AI, it provides the foundation, the platform for providing these rich contextual applications, but it also provides the best platform for your AI initiatives. And I'm interested to hear the customer stories as we go forward. So I'll wrap with sort of a final thought. Every step of the evolution has value, right? Relational technology is still important. Basic search is still important. Booleans are still important. All of these things build upon each other. But really, when you bring them all together, the greater the context, the greater the insight, the more effective you will be with your AI initiatives. All built on the Progress Data Platform, which MJ is going to detail after the break.